How y'all doing? Oh, that was lame. What? No F-bomb? So,
I'm doing great, and thank you for asking.
It's nice to meet you too. Good to see you. So, my name's Royse, and this is jQuery and 10,000 global functions, working with Legacy JavaScript, or as I like to call it, pre-agile JavaScript. We get these old applications; they're kind of crufty. The JavaScript in them is kind of hard to work with sometimes, and I'm going to talk about why that happens. And I'm going to give some examples, some techniques that I use to remediate these old legacy JavaScript code bases. And I have a kata, but we're not going to get to it. We don't have enough time. But you can check it out afterwards. It's on GitHub, where I wrote a really, really, really awful application. It's a store that sells just eggs. And you can try and remediate that code and put it under test. So that's what we're going to be doing today. So who is this guy? So this is actually the photo they used as the basis for my little caricature that Star Trek made, which is, I think, perhaps the most awesome speaker gift I have ever received in my career. Props to Star Trek and the organizers and the sponsors for making that possible. I like to eat turkey legs at Ren fairs, apparently. That's where this photo was taken. My name is Royse. I got my Twitter and email and my blog that I haven't updated in a year and a half, link on there. And I work for Pillar Technology, where I write awesome software. I like to think it's awesome. I work with awesome people who write awesome software, and I help them out. And I teach sometimes. I run the JavaScript user group, and I've been developing for over 20 years. I've got 30 years of JavaScript experience. And 35 years of C+ of Java experience. Yeah. I know both Java and JavaScript because they're the same language, right? Yeah. I heard a joke a long time ago that Java is to JavaScript as car is to carpet. That's really the relationship there. So anyhow, so this is me. Enough about me. How many of you recognize this picture? All right, we've all done this. This is the box arrow cylinder architecture. And you know, we know the labels, right? What's that first box? Yeah, it's the presentation tier. And the middle box is the business logic. And the back box is our data store, all right? It's this. We've seen this a million times. It's a 3-layered architecture. Every application uses it. Of course, there's a lie embedded in this. There's a couple little lies. It's slightly wrong. So for one, it's not really the data store. The data store is the physical store. The cylinder represents a hard drive, a disk, that is the actual storage of the data. But we don't write that generally. We write code that accesses that. So really, we got presentation, business logic, and data access. And so really, it's another box. It's not a cylinder. But this is actually an overgeneralization. This is actually an overspecification. This is too specific. This is actually a more general problem. This is what these really are. There's our concern. That'd be the concerns of the client. In the case of a big application, that would be the user. You've got their concern. That'd be the things we're interfacing with. The databases, the web services, the external APIs. All the things that our code needs to interface with. And then you've got the mapping in the middle. That's the bit of the code that takes that one format and presents it in a format that users care about, and takes things that the user cares about and shoves it into a format that our external APIs and data stores care about. This is, in some ways, it's input, process, output. I remember years and years ago in college when I was actually learning COBOL. Pray for me. That was how we organized all our code. It was input, process, output. And so this is actually nested. So inside of our presentation, there are 3 layers. There's our input, our process, our output. There's our external view, our stuff. There's the stuff on the back end, their stuff. And then there's the stuff in the middle that converts between the two. And this is turtles all the way down. right? So your presentation tier is made up of pieces that talk to the business logic tier and present things to the user and map between them. And one of those components in your presentation tier, maybe it's if you're doing like JSP or something like that, it's a class, but in the case of JavaScript, it's going to be JavaScript modules. Well, it's going to have things that are external to it that it cares about. It's going to have a public-facing API, a client, the interface, and it's going to have the code in the middle. And so this sort of their stuff, our stuff, and the stuff in the middle is just even if individual functions have this pattern, it goes all the way down to the lowest level of our code. Am I making sense? So you're all wondering, what's this have to do with JavaScript? So I just thought this picture was really funny. Well, JavaScript has traditionally been shoved into that presentation box. Right? And so on the presentation you'll have, let's say you're doing a Java application, you've got JSPs, or you're doing a .NET application, and you've got ASPX files, ASP.NET stuff. Or you're, heaven forbid, working on a really old Microsoft application, you have old DNA architecture, you got the .asp files, or you got PHP files, right? So you got those on the presentation, and then you've got some JavaScript as well, and that's kind of your JavaScript code. And that JavaScript is just sort of treated like, well, it's the presentation tier, so that's the structure. And so people write just one big transaction script. It's just one line of JavaScript. Okay, when I click this button, I need to do this, and I need to do this, and I need to do this, and this thing's going to call it here, and then I'm going to add this to the DOM, and then I'm going to call it another thing and add it to the DOM. And you just sort of get this vomited out set of code that has no structure. Oftentimes has no named functions that you can invoke through any type of unit testing. And so this is ultimately a result of not treating JavaScript, not treating the presentation as having tiers of its own. And this problem exists in all the tiers. You can do this in the middle tier. Oh God, can you do this in the middle tier? With I've seen some JavaScript or some Java code that would make you go home crying to mom. It's just awful. And even on your data access stuff, it's like, oh look, I coded the entire application in SQL. That's legacy code. Good luck testing that. And so JavaScript is not viewed as being part of these three tiers. And so people just write out a bunch of code. And this is ultimately a failure of architecture. So an architect's job is to provide a strategy. I just think this is hysterical. You know it was totally on purpose, right? They got the tattoo as a joke, but it's still really funny. Either that or it's totally photoshopped, one or the other. So the architect's job is to guide the technology direction of that application. And I don't know how many times you've heard this, but I've heard this many times. I'm a back-end developer. I don't do front-end work. Because it's messy. Well, it's messy because we didn't put any structure around it. A lot of architects grew up when that was really the bulk of what we did. And they've gotten to a point in their career where now they're architects, and so they focus on the thing that they know, the back-end Java or the back-end C# code. And they kind of ignore the JavaScript a little bit. They're not sure how to pull it apart and put some structure to it. And so you don't have any strategy. Instead, you just have drift, where everyone just kind of does whatever they feel like doing. And so you end up with all kinds of stuff. You end up with this. That's actually from my website. You'll notice up there that it says title guyroyce.com, pipe blog. Yeah. Actually, I wonder, could you use the poo emoji as a variable name? Can you use it inside of a variable name? Can it be the first character? I know one time I was writing code and I put an accent mark on the word resume on a class name, and my coworkers shot me. How do I type this? You know. But yeah, so you end up with a pile of code that looks like this, right? I mean, this guy's warm and happy, but you're not. Yeah. So what do we do with all of this code? We got this mess of code, and someone wants us to change it. Of course they want us to change it. That's what we do. How many of you work on existing systems that have code that you wish were a lot better? Right? And how many of you get to do the glorious greenfields projects all the time? Exactly. We all have to deal with this code. And it turns out, actually, we created a lot of this code, right? When we're smart now, but we were dumb back then. And 5 years from now, we're going to be smart and dumb today. That's just how it works. So there's a couple of solutions that immediately come to mind. We need a framework. The reason our code sucks is because we used the wrong framework, or we didn't use a framework. So we need to move to something modern like MooTools, or Sprout Core, or Dojo. I actually worked with a client where we had to try and put tests around Dojo. Actually, I see someone in the audience that did that with me. Boy, that was a pain in the ass. Not happening. I got Backbone in here. Now, I say this because we all say that this code sucks, we need to use Angular. And then we're like, this Backbone code we wrote is very dated and it's full of all these bad if statements and it's deeply nested, and so we need to use React or whatever the framework du jour is. Well, here's the news flash. The code doesn't suck because it doesn't have the right framework. The code sucks because it was written that way. I can write good code in MooTools. I can write good code in Dojo. It might be a little hard to test, but you can write good code there. I can write good code in any of these old tools. I can write good code in any of these modern tools. I can write bad code in any tool I want. I can write bad code with no tool whatsoever. The quality of my code has nothing to do with the framework I'm using. Getting a framework to solve your problem it's not looking at the problem. Sometimes I think we do this, honestly, to pad our resumes. Can't say that I've never had that thought. It's like, I want to work on this project and use Angular, then I can put that on my resume. But see, legacy code bases are kind of like people. So, some people are kind of, well, every person really is broken and flawed in certain ways. And if you go to them and you try to interact with them in a way that says, you really need to not be this and be this instead, they're just going to shut you out and ignore you. You got to meet them where they're at. Legacy code is like that as well. You got to meet it where it's at. I have seen applications that have 3 or 4 frameworks in it. I worked on a particular application. It originally had Prototype. Remember Prototype? Back before jQuery? It had jQuery as well as Prototype. Both used the $sign. That was fun. It had some Angular in part of it. And then we were in the process of adding Knockout. So have we, by swapping out that code and putting in a new framework, have we made the code simpler and better, or have we made it worse? How many times have you said, you go to the person with the money and say, hey, we need this big pile of money so we can switch from this tool to this tool. And then they say no, because it doesn't add any business value. And so we compromise and we say, well, I'll use this tool for all the new stuff and any of the stuff that we have to touch. And then we'll go back and change the other stuff as we go. We'll do it later. And later is never. We never go back to doing it again. And so we've made the code base worse instead of better. I would rather deal with a well-written MooTools application than a badly written Angular application any day. Because I can understand what the code does. Does it use a dated library? Yeah, sure. They're all going to be dated someday. But having that multiple number of tools in those libraries in your application amps up the complexity. You've made the problem worse, not better. Meet it where it's at. The other solution we come to is that we need a rewrite. This is a big block of text. And it's quoting Uncle Bob. And I'm just going to read it because I think it nails it. How many of you have read clean code? That number should be higher. You should go out and read it. It's fantastic. So he's talking about the need for a rewrite and what happens. A new Tiger team is selected. Everyone wants to be on this team because it's a greenfield project. How many people want to be on a greenfield project? Oh, that'd be great, wouldn't it? They get to start over and create something truly beautiful. But only the best and the brightest are chosen for the Tiger team. Everyone else must continue to maintain the current system. Now the two teams are in a race. the Tiger team must build a new system that does everything that the old system does. Yeah, yeah, I have too. Totally been there. Not only that, they have to keep up with the changes that are continuously being made to the old system. Management will not replace the old system until the new system can do everything that the old system does. This race can go on for a very long time. I've seen it take 10 years. That's a waste of money. And by the time it's done, the original members of the Tiger team are long gone, and the current members are demanding that the new system be redesigned because it's such a mess. Lather, rinse, repeat. We need a rewrite will not happen. They will not pay for it. If it gets so bad that they will pay for it, you will end up in a race. It will not solve your problem. You need to fix the code. You need to meet the code where it's at. That's really the only solution. The real solution to dealing with legacy code is the same way that we eat an elephant. And this is my inhumane diagram of how you butcher an elephant for consumption, because I'm a horrible person. There were better ones online, and just Google image these things. I'm sure I'm violating someone's copyright. And that had like the shoulder and the ribs and the loin and everything all, but this one looked best for the slide. We have to eat the elephant one bite at a time. We all know this. We've all heard this, right? That's the only solution. We have to do a little bit at a time, make that code better. Don't add things to it to try and sort it out. Or if you do, be very judicious. Do not add big things. Do not add an entire new library that's going to restructure the entire application. You got to meet it where it's at. And it's going to take time. It's going to take years. But over time, the code will get better. And there's been a really great book written on this topic. I'm sure many of you have seen it. Working Effectively with Legacy Code by Michael Feathers. It's a fantastic book. It does have one problem when it comes to JavaScript. A lot of the refactoring techniques that he tells you to do. So basically, I'm going to go through the slide, the little flow chart here first. So we start out with a big mess of untestable code that we want to modify. And so, but we can't get to it. And so we do a very careful refactor of that code without any tests. I know, craziness, right? That's the essential step is you do a very careful refactor, a simple refactor, pull that out into a function or a module so I can get to it and run it through a test. Then I have code that's testable. Once it's testable, I start writing tests against that code until I've proven that that code does everything it should do. Then I can write a failing test and start my modifications. Yes, sir?
When we did a major refactor, we built a bounding test to play around the entire system, so that as we built a new one, we would constantly re-verify that it was producing the same result.
Yeah, so what he said was that they did a refactor and they built a bounding test around it, a test at a higher level. So like this would be like writing a cucumber test that goes out and pushes buttons on the browser to verify it works. And then you can go ahead and pull that thing apart a little bit and then put unit tests at a lower level. And that can work. Sometimes that's not an option. Michael Feathers doesn't talk about that technique specifically in his book. And sometimes that can work sometimes. That's not a bad technique at all. I have used that. Sometimes what can kill you with that, though, and why it can fail, is that if the number of permutations that that test has to verify are really high, then the test is too hard to write. And so you need to write unit tests and then a few higher level tests that verify those unit tests work together. Otherwise, you run into a problem of permutation. But sometimes you can do that, and that's a very helpful technique. So the very careful refactor happens, this book has a bias towards compiled languages. So C++, Java, that sort of thing. And in those languages, if you got a function, you're like, it's marked public, but is anyone actually using it? You can just mark it as private and then compile and see if it breaks. That's great. You can't do that with JavaScript. You have no idea whether anyone's using that until you run the application. So that's not as easy to do. It's just harder. And so I've come up with some ways to sort of mitigate that a little bit. It's still just harder to refactor legacy JavaScript than it would be to refactor a compiled typed language, a statically typed language. But that's what it is. So that's sort of a problem statement. So let's get on to the crunchy bits. I always eat veganic sprouted ancient maize flakes for breakfast. Breakfast of champions. So some of the crunchy bits here. So you might have an old JavaScript application and you're like, well, let's go ahead and if we could use ES6, that would make a lot of these problems, this code cleaner and help us clean it up. Well, I'm not going to talk about that. And the reason I'm not going to talk about that is because that's a variation of we need a framework. The problem isn't that you can't write clean code in old JavaScript in ES5 and below. The problem is that the code wasn't written well. I can write clean code there. I can write clean code in ES6. So adding a new technology that you only use in part of the application isn't going to solve your problem. So I don't talk about that because all these legacy apps are written in ES5 and below. A lot of them have to run in IE8. Maybe. I don't know. Is anyone still using IE8? Okay. Anyone using 6? Hi, Grandpa. How you doing? So there's some of that. My notes are not showing up in here. Let me see there. There we go. That'll make things easier. Also, we're not interested in taking a existing application and turning it into a single page application if it's not one already. A lot of these apps are, I've got some sort of server-side rendered HTML and I got some JavaScript on the front end to make it nicer. Or I have some stuff to do some AJAX calls, but it's page-oriented. You hit that page, you hit a link, it takes you to another page, it's rendered. Trying to collapse that all down is a major architectural change. And so this talk's not going to be about single-page applications. It's just about taking bits of JavaScript and with these static pages and making them cleaner. All the legacy apps that I've run into tend to work this way because they're things that JavaScript is added to later. So 2 caveats. Basically, there are two more variations of the don't add a new technology to an existing messy code base, meet it where it's at. So after this, I've got a series of slides where I sort of got a taxonomy of various problems and how I approach them. And then we'll be done. So that's the rest of the talk. We'll have some questions, and then we'll be done. Sound good? Okay, so problem 1, the sizzle. I have some HTML code. I have some JavaScript code in the HTML that does like a rollover, and it changes the background color or something along those lines. And it's all the code's embedded in the HTML on the on enter and on leave, on mouse enter, on mouse leave events. The attributes that are actually in the HTML tag. How do I refactor that code to put it under test? The answer is that you don't. The answer is that you use CSS. So here's some sample code, and hopefully that's readable. Unfortunately, the lights are still on. I was hoping we could get them dimmed. But how readable is the red tech code up there? And you guys okay? Okay, I was concerned about this, but I couldn't come up with a better color scheme that would accommodate both red and green. So here we've got a script tag that has a very generously named function called add drop shadow, which sets the background color to black. It's a very aggressive drop shadow. And then there's a remove drop shadow. And then here we have an anchor tag, which has an on mouse enter and an on mouse leave, which calls those functions, passing in the current element. And then we got an href. You can refactor this to simply use a hover tag. A hover, I don't know what you call those things, but the little colon things. And set the background color when it hovers over it. And then you don't have any JavaScript to test. So I know I always talk about TDD, and I push TDD and testing all your code, but this is a UI concern. You don't need to test it. So just refactor it to add a class, add a style that does it. CSS will do a lot of the things that really old JavaScript used to do. This is just code you can remove from your application, and everyone wins. Code in the HTML. How many people have got applications that have this in it that they're dealing with? All right, yeah, we all do. I've got code in HTML. It cannot be loaded into a test harness to test it. So the trick is to move the code to a JavaScript file. Just copy and paste. It's a very safe refactor, and add a script tag to reference it. If you've got like on-click handlers embedded in your HTML, you can replace those with jQuery or an appropriate tool if you don't like jQuery. But my odds are the app you're dealing with probably has jQuery in it already, so you should probably use it. So here's an example of what that looks like. And these are pretty simple things to do, but they're early first steps to safely get that code out of the HTML so that you can actually execute it from a unit test using Jasmine or your testing framework of choice. I like Jasmine. It's what I tend to use. So here we have a script that has a function in it embedded called doAwesomeThings, and it calls thing.doAwesomeStuff, passing him awesome app is awesome. And so what we do is we refactor. Did I just check? Okay, yeah, still good. Okay, I heard a blip there. So we pull the script out and put it in a separate file, and we just add a script tag. As you can see in index.html. We give the anchor an ID so that we don't need an on-click handler anymore. And then in our awesome.js, we add a click handler, and we add the function that does the awesome thing. Then in our spec, we can spy on thing.doAwesome on thing, call the awesome thing clicked function, and verify that it in fact did do an awesome thing. So this allows us to now test this function, whereas before we could not. Again, these are pretty straightforward refactors, but they're very useful. DOM interaction. So I got all this code that interacts with the DOM. But I don't have a DOM in my JavaScript. How can I, for my test, how can I do that? Well, you can have a DOM in your unit tests, and I use Jasmine jQuery to solve that problem. And so here we've got the similar code here. We've got the awesome.js, and we've got the awesome thing and a div. And in awesome.js, we have our click handler. And we have our click binding and then our handler down here. And then we, in our tests, we call set fixtures in a before each. And set fixtures will create fake HTML that we can then interact with. And you'll notice that the div has an ID of to be awesome, which matches the div in index.html. And then we can just call the onAwesomeThing clicked function and then validate that the HTML has the content that we want. So Jasmine jQuery makes testing this DOM interaction really slick. Questions so far? Cool. I have functions everywhere, man. This is the eponymous problem. So what you end up with in a lot of these jQuery apps is a lot of people have figured out that they probably shouldn't put their JavaScript in the HTML. And so they put it outside of the HTML in a .js file. And then they got lots and lots and lots and lots and lots of global functions. So, and I mentioned earlier how in JavaScript we can't just make one of those global functions, we can't just move it into a module to sort of provide some structure and organization around it. Because if we do, we don't know who's calling it. And we could search our code base and do a string search and try and find it, and that will find most of them, and many times it'll find all of them. But that function could be assigned to another variable somewhere else. It could be in an array. Because it's JavaScript, you can pass functions around. God knows who's using that function and where it's at. It's not always obvious. And so we want, and also we don't want to have to refactor all of our code. We just want to refactor the bit we're working on. And we got this function, and we want to put it in a module. So what we do is we create a variable. We go ahead and move the function to the module. And then we create a variable that is assigned the value of the function that's in the module. And that preserves a backwards compatibility, so we still have the global function. But at the same time, our new code can use the modularized stuff. So here's an example of it. I've got 3 global functions: transmogrify, transmute, and transform. And I want to refactor them to be in a module called mutators. So I create that module. I assign create 3 functions for transmogrify, transmute, and transform, and then I assign global variables that point to the modularized, is that a word? Yeah, modularized function. And then in my spec, I can validate that the global function is the same as the one that's in the module, and then I can validate the function in the module does stuff. So this is a way of preserving backwards compatibility while slowly cleaning up your code base. Eventually, you will be confident when you have enough tests around your code that no one is using the global function anymore, and you can remove it. It may take a while. No units. How many people have seen this code before? Right? So you've got an HTML file or a JSP or something, and then it brings in this script file, and the very first line of that script file is $, and then a parenthesis, and then function, and then there's an anonymous function there. And so that's jQuery's way of doing an on-document load event, and then it starts running that code, and then it makes an AJAX call, and that AJAX call has an anonymous function that's callback, which then manipulates the DOM using just more jQuery selectors, and then does another anonymous callback. And you get all of these functions that are anonymous, but none of them are named. And so if I load this file into a test harness, into Jasmine, it's just going to run. It's not going to produce any units that I can actually execute against. The solution, of course, is to extract those anonymous functions into named functions. And the first instinct is to make a named function that is a global. And that might be okay, depending on what your code base looks like. But eventually, you'll need to refactor that into a module pattern. You can very easily create a 10,000 global functions problem. So here's an example of some code that has all anonymous functions. So there's the $, and then when the document loads, it interacts with the DOM to get an ID, makes an AJAX call with that ID. When the AJAX call resolves, it then takes the name, rank, and serial number from the data and puts it into the DOM. So what we've done here is we've instead extracted out that function into fetch and update DOM. And then we call that on document load. And actually right here, the first 3 lines of green JavaScript code, we could just pass that function in. We don't actually have to make a function call there because JavaScript works that way, but I thought this was a little cleaner. Everyone always calls it out, so I thought I'd just preemptively shut them up. And so the fetch and update DOM function then goes out and gets that ID, makes an AJAX call, and then when that AJAX call comes back, it calls update DOM. And again, that could have just been inlined. And then update DOM then proceeds to update the DOM. Now I've got 2 functions that I could test. I can write tests around these functions now because they're named things. I happen to have created 2 global functions that could very easily be in a module. jQuery everywhere. I've got inline jQuery calls all over my code. This is basically my app's implemented as a transaction script problem. So you'll see this a lot where you just sort of make AJAX calls and DOM manipulation calls just kind of wherever you need them. And then it's hard to figure out where the DOM manipulation, there's just no structure to that code. It's hard to figure out what's going on. It's hard to pull it apart and think about it. And so what I do in those scenarios is I take my jQuery calls and I put them in create a module full of functions that do the jQuery thing. And I create 2 of them. I create one for the view. I use a passive view pattern where all the jQuery calls that manipulate the DOM are at, and they're stupid. They're rock dumb. It's like, get the value of this text box. Okay, there's a function for that. Set the value of this paragraph tag. And it just has the ID and the selector embedded on them, but nothing else. It's not applying any logic at all. It just reads and writes to the DOM. It does what it's told. And then I'll do the same thing with my AJAX calls. I'll wrap up all my jQuery that calls my AJAX, makes my AJAX calls into another module. what you end up doing here really, here's the sample code, is you end up creating a view and a data adapter. Remember those 3 boxes? Right? These are 2 of them. So jQuery tends to be the technology we use to manipulate data from our JavaScript to go adapt to their stuff. And jQuery is also the tool we tend to use to put things in a user context on the screen. And so you can see here in this example, I created a var view equals, and I got ID, name, rank, and serial number. And ID doesn't take a variable, but name, rank, and serial number do, and they just do basic DOM manipulation calls. They go out and select something by an ID, and set the value or get the value. The data guy, he's got a function called fetch, which goes out and you hand it ID, a callback, and it goes out and makes the call and returns it back. Now all my jQuery is compartmentalized, and I've got this function down here called fetch and update DOM, and it just has to coordinate between the data and the view. Or you might even say control it, like it's a controller. So see, there's your third. So this is the MVC pattern in JavaScript. And if you look at those 3 layers, MVC fits them, right? You got the view, that's the user stuff. You got the model, that's the external stuff, and then the controller is that adapter in between. Although I will say, don't put your business logic in your controller. You're probably doing that wrong. But this helps you start pulling apart these legacy apps. And then these things are, of course, completely testable. It's a module, and you can use the techniques earlier where I'm talking about injecting a DOM using set fixtures. I can do that, and then I can test my view and say, hey, when I call this function, the DOM changes, right? And now I know it works. And when I go I add a thing to the DOM and I go read it, it's there. And so, same with the data, you can mock out jQuery's AJAX calls using Jasmine spies, or you can use a tool like is it Jasmine AJAX or something like that? I've used in the past that will create a mock AJAX call as well. Also, another way to handle it. But yeah, this helps you pull all these global functions into something, all this jQuery into something meaningful. And if you didn't use these modules, you'd end up with 10,000 global functions, which is also an anti-pattern. So, let's see. Really ugly for loops. You've seen these, right? How many times have you written the for loop whose purpose is to loop over an array until you find a particular thing, and then you break out of the for loop and you assign it to the variable? Right? I know I've written that code. Well, if I had got a nickel for every time I'd written that code, I'd have a big pile of nickels. And a friend of mine who collects nickels would be very happy. These kind of loops are hideous. A lot of these things are solved problems, and you don't really need to implement your linear search algorithm using a for loop or a linear conversion where you just map all that content to new values or any kind of filtering like that, because someone's written all those for you. Actually, JavaScript has several built in if you are lucky enough to be able to use a version of JavaScript new enough to support that, which is a lot of us. I wouldn't say it's most of us, but it's a lot of us. If not, you can add a library like Lodash or underscore, which are fairly unobtrusive and can help make that a lot easier. So I'm just, in my sample here, I'm just using the out-of-the-box functions in JavaScript on the array object. And so you've got these for loops here where you want to sum some values, so you just loop over the values and keep adding them to a sum. You have a one where you want to get just the even ones, and so you just loop through them and keep adding the even ones to an array. And you've got one where you want to double everything, and so you just call it and map it by pushing it to a new array and multiplying the value by 2. These are all solved problems with reduce, filter, and map. So reduce, it does the same thing. It takes the array and the function you pass into reduce, it calls it with the value that's in the array, each value, 1, 2, 3 down the line. And then the previous is whatever you return from the first call, the previous call. And so you just add them all together, and then when it's all done, it returns the value that it reduced to. So it takes an array and reduces it down to a single value. Very powerful. I'm sure many of you have seen this technique. It's very helpful for your JavaScript. And it's just one of those things that cleans up your code, makes it easier to reason about. Filter does a similar thing. Each function is handed the element in the array, and then you can return true or false. If you return true, it's put into a new array, which is returned. If you return false, it's not. And map works in a similar fashion, except you return the value that you want to have replacing the previous one. So it takes an array and takes the 10 items in there and maps them to 10 new items using whatever algorithm you pass in. These are basically variations of the strategy pattern, and JavaScript makes that kind of stuff really easy. Okay. And so you can use Lodash or underscore or the built-in stuff. I think everyone's kind of trending towards using Lodash now versus underscore because it's more performant and it has a cooler name. I'm not sure why everyone's transitioning to it. It's got a few more functions in it. That might be part of the reason. Project I'm on right now, I'm using Lodash. They're both perfectly suitable alternatives. They're almost the same. Really long functions. This is sort of a universal problem. So you see this in all kinds of languages, but also in JavaScript. You have a really, really long function that does a whole bunch of things. And so you've got all these variables that are defined at the top of the function, and then you've got all this code that manipulates those variables and then finally returns something. So it turns out that a class in a traditional language, or in the case of JavaScript, a revealing module, or you could use the class if you're using ES6, if you're fortunate enough to get to do that. A class is a bunch of hidden data and some functions that manipulate it. So those really, really long functions you see are classes waiting to be factored out. So in JavaScript, you can put a test around that function, and then you can refactor that to some sort of revealing module pattern. And so here we've got an example of that. I have a function called doMaths, because I'm British, obviously. And it takes x and y, and it does the 4 basic operations against it. Adds addition, subtraction, multiplication, division. And then it returns an object with the results of all 4 of those computations. Now, by itself, actually, this is not bad code. And in reality, I wouldn't refactor this code if I ran into it. But it shows an example of how we can take that addition, subtraction, multiplication, division, and refactor that to functions. What you see down here, you see function add, function sub, function multi, and function div. And then this mather object is interesting because for those who haven't used the revealing module pattern before, you see here I've got a function. And at the very bottom, I don't know if you guys can't see my pointer, but at the very bottom of that function, we immediately invoke it. So we got this anonymous function in which we immediately call. And that creates a closure where we can store private things. So in this case, we create variables for x and y that are passed in on the doMaths function. We name them underscore x and underscore y. I used to think that underscore convention was a throwback from Hungarian notation, but actually I was told that it predates that, and it has to do with old C like makefile implementations or something that I've never had to deal with. But so our doMaths assigns those private functions and then calls the add, subtract, multiply, and divide, which are also private, and then returns the value. This whole anonymous function returns an object it has called the doMaths function exposed on it. So this allows us to take a really big function and turn it into a class in JavaScript. You can also use, if you are doing ES6, you can use the new class construct. I actually don't prefer it because it doesn't allow me to do privates. And this pattern allows me to create privates. So I prefer this. Almost duplication. How many times have you ran into that code where I've written 4 variations of this function, and they're all almost the same, except they operate against different things. We've all been there, right? And so you can subdivide that into helper functions and say, well, do the common parts in these helper functions, and then we'll just sort of have this loop that does the common thing. But in JavaScript, I like to do a pattern called a Lambda factory, or a function factory, because you can do this kind of stuff in JavaScript, and I think it's kind of neat. And I probably like it a little too much. But here we've got a sample where we want to create a function that gets the first, second, and third number out of the DOM and multiplies it by the value you pass it. So here we call get first number, pass in an x. It goes out and parses the number out of the DOM and then multiplies it by the number you passed in, right? And we got 3 variations of that. You could refactor that to call another function which gets number times, and then that takes the CSS selector or the jQuery selector and the value you want to multiply with, and then write a little helper function that does that for you, and that's perfectly acceptable. But you can also do these Lambda factories where I can create a function that returns a function. And this is the stuff I love about JavaScript. You can do stuff like this. And so you pass that function, the function factory, the Lambda factory. You pass the Lambda factory the CSS selector. And then that factory returns a function that takes x and references that passed-in variable from earlier. So you've sort of created a templated function. And now I got a little factor here. I can say get times function. I can just pass in the selector. And if I only had 1 or 2 of these, I totally wouldn't do this. But if I had 20 of them, oh, you betcha I would do this, because then my code becomes very declarative. Hey, yeah, we got a function called this, and it's this, and you can just sort of kick them out. Makes, I think, for pretty clean code. So I like this pattern. I think I have a bias towards it because I think it's neat. And I think it's kind of clever. It's probably a mistake. I find if I'm trying to get clever, I'm probably doing things wrong, but it's a neat pattern nonetheless, and I'm sharing it with you. So back here, I talked about creating this mather, which creates sort of a static object in memory. It creates a global. And that can be okay, depending on what it does. But lots of times you'll run into the problem of side effects when you try and test it. So I've got this global object. Everyone uses it. It's fine. But when I go to write a test against it, my tests, when I change the order of them, it breaks. This is painful in all languages. If I've got to run my tests in a particular order, you just drive yourself nuts because you have to think too much about what's going on. Now here's an example of this. This is a problem of using a global. So what I do is in the bad code here, we've got a stateful thing. And it's got a name, and then you can get the name and you can set the name. And the name is defaulted to Alice. And then so you see we got this revealing module just like we talked about earlier. Below it, we have a test which doesn't work. We assign the stateful thing to subject. We set the name to Bob, and we validate that, in fact, the name is Bob. That works. And then we validate that the name defaults to Alice, and of course that doesn't work because we just changed the name. Right? Bad, bad, bad. Bad programmer. No donut. So the way you fix that is instead of having the stateful thing, you create a factory for the stateful thing. There's lots of ways to do this. I just used a function. And so we got the stateful thing factory, which then it's basically the same code where we set the default name, we got a get name and a set name, and we return an object that has the getters and setters. And then the line right under that in app.js, we set the stateful thing that's global to a call to stateful thing factory. And so now we have a global version of this thing. So all the existing code is preserved for backwards compatibility, but we can call the stateful thing factory in our tests and validate the behavior of the stateful thing. So it's not so stateful anymore. I guess it's still stateful, but we get a new copy of it each time. So you see here in the test, and before each, we get a new stateful thing for each test. And that avoids those side effects. So my next slide is big, and I don't think I'm going to go into all the detail of it because it's a big topic. It's a topic all its own right, but I'll talk about it and point you in a direction. And that's the pyramids of doom. How many people are familiar with the pyramids of doom? A couple of you? So we've written a couple of these already. This is that, it's also called callback hell. So the pyramid of doom is the anti-pattern where, well, I call this thing and then I pass in the anonymous callback. And then it does another thing with another anonymous callback, and we make an AJAX call, and we do some DOM manipulation, and we go out and get our GPS location or whatever, and we got all these anonymous callbacks, and we just keep tabbing in until we get this code that's shaped like a giant greater than sign. It's a chiastic code. There we go. That sounds smart, doesn't it? So you get, chiasm is just cross. It's an old literary technique used in ancient texts, and it makes this sort of shape like that. Our code ends up looking that way, and that's an anti-pattern. It's hard to read, it's hard to debug, it's hard to test. And promises are really, really good at solving this problem. And I'm not going to go into how promises work other than to show them here. But if you're running an existing legacy code application and you want to start using some promises to clean up this code, there are promise libraries available. You can use Q. That's the one I usually use. For no particular reason, then it's the one I always use. If someone had another one and a reason, I would use that one instead. It's not really not the biggest choice. jQuery has these built in as well. You could use jQuery's promises. ES6 has it built in as well if you're using ES6. So, but really you've got this sort of asynchronous anonymous Lambda, which is a big fancy word for an anonymous callback function that gets back to me whenever. We use these all the time in AJAX calls. So we'll do $.get URL, callback function in our JavaScript. And that callback function is anonymous because it's not named. It is a Lambda because it's that function thing we pass around. And it's asynchronous because we're making a network call and it will get back to us when it gets back to us, if it gets back to us. And these anonymous asynchronous Lambdas can be greatly improved with the use of promises and a lot of the other techniques here. A buddy of mine said the anonymous asynchronous Lambda is the new go-to, which is a pretty bold statement. But they do make a mess, and you don't know when they're going to resolve. So, but promises will help with that. So here, you guys can, if you want to look at the slides, I'm not going to talk through them because I only got 5 minutes left, and I want to have a little time for Q&A. But and promises is a big topic. You could do an entire talk on promises if you haven't done them before. Check them out. They're totally awesome. They help make your code not suck, or at least suck less. So that's all I got. Any questions? Yes, sir. These slides, I'm going to be putting them on SlideShare. I've also recorded this talk, so hopefully it'll end up on YouTube. It's possible that the audio will totally suck because it's just my MacBook's microphone. So yeah, I'll get them up on there, and just I'll announce it on Twitter when I do. So you're very welcome. Yeah, it's sort of I've thought about turning them into a series of blog posts because they're kind of, it's sort of like a little taxonomy of common problems and ways you can deal with them. So yeah, I'll totally get those up. Yes, sir. Have I found a good way to test promises? Actually, promises are pretty testable. So in Jasmine, you can always if you've got testing a code that returns a promise, you can create a promise that just resolves immediately, and then boom, you're good. And that pretty much takes care of it. There is some asynchronicity that happens there. So in Jasmine, you can pass in done as a function. You take the argument done on either your before each or on your its, and then you call that when the promise resolves so that you preserve that asynchronicity. That allows you to test asynchronous code with Jasmine. If you're using Mocha or Chai, Mocha and Chai, there's a library called Chai as Promised, and it has some really nice handlers for promises. So you can do things like expect call to something to eventually be this value, and it will resolve that promise. And if the function returns a promise in Chai, with Mocha Chai as promised, then it will not finish testing the it until that promise is resolved. So it makes that pretty helpful. It can still get a little hairy when you start dealing with asynchronicity, because there's the execution queue or stack in JavaScript, and that can get hairy. And depending on what you're doing, there's also microtasks and macro tasks, and it can get really hairy behind the scenes. And so it's still tricky. Asynchronous code is fundamentally hard to think about. And promises give us a metaphor for dealing with the asynchronous code, but it's still asynchronous, and it's still hard to think about. Our brains aren't wired for concurrency. I mean, there's three big problems in computer science. There is dealing with concurrency and off by one errors. Boo! Actually, naming things is the third thing. But, any other questions? Back there, want to fight it out? So what are the problems, how do you get Jasmine embedded into an application? I've actually found Jasmine's pretty amenable to being injected into things. The hard part is just getting to the JavaScript files in the first place. The simplest thing you can do is you can create a spec runner HTML and just, or I like to use Testum sometimes to make it headless, and just get to those files. If I can get to those files and load them in that HTML file, then I can test them. And I can just ignore the existing HTML. The set fixtures thing is just a matter of, you're basically creating mock HTML at that point. And so that's pretty straightforward to do. You just need to know what your HTML is that it's interfacing with. So.
And it can mock AJAX calls?
Yeah, well, Jasmine will, I'll usually just spy on AJAX. So Jasmine has the capability to do spies. So I can spy on $, and then the get function, or $, and the AJAX function. And then you can, once you have a spy, you can tell it to call a fake version of the function or return a particular value or whatever. In the case of AJAX, I call a fake function, which calls the callback and hands in bogus data. That's how I've solved that problem in the past. So I hope that helps. It's a real quick answer to a big question. So yes, sir. I try to. If I can't, then I still have them because they help me. But if you don't have CI, then it doesn't keep anyone else from breaking your stuff, and so that's important. If I need to do that, I'll use something like, I usually use Testum. Testum will run all your tests in Phantom.js for you. What's the other one? There's another one that does that as well. I can't remember what it's called. Maybe it's Karma? Yeah, Karma. That one seems to be more popular. So I guess I'm not doing what the cool kids are doing. But there is some caveat there, is that Phantom.js is not necessarily going to behave the same as a browser as Chrome is, for example. I've run into some problems with that specifically, where if you're doing something advanced, it's always hard, right? That's why they pay us, right? If it was easy, well, there's a joke there, but I'm not going to say it at a conference. So that's my answer. I hope that helps. And I'll be here eating lunch here too, so feel free to bug me afterwards. Any other questions? Cool. Well, thanks a lot. Feel free to make fun of me on Twitter.